Very good. Yes. So, what kinds of doubts you have regarding the lectures, right? Uh, so question number 7, I understand. Yes, Arun Akpal also wrote he has a doubt. Okay, I will try to solve that. Yeah, I'll do that. I'll try to solve it. That is one. And anything else? Actually, this perturbation things have a lot of mathematical calculations are there. So it was also tough for me. Uh, from the lecture, variational theorem is. Uh, we find e dash, yes. No, not really e dash. E. We found generally e, which is closer to our original energy, uh, and eventually that energy minus the actual energy may be, yeah, solving the secular determinant. Yes. So from the acha, one thing we'll do that after solving this assignment problem, I think it will be done soon. Then I will try to check the whatever professor's slides are there. Then we can discuss that from there. That how to get the E from there. So it's almost 6. Let us wait for 1 or 2 minutes. Maybe 6:03. I know means Arun Paul not join today. He's not well, I guess. So if any others are joining, let's hope after 6:03 or 6:04 we will start. Till then, let me also check the I have the slides or not, because soon we are going to share these slides in a PDF format with you. I don't have all the slides. Maybe in between 3 or 4 slides are missing, but we have collected almost all the slides, and soon we'll share this PDFs. Actually, in PDF version we'll share. So I have already given these things to the NPTEL member who is cooperating with me. So he will soon share these slides. Let me also check if I have the so the register. I don't think I have. Register. I don't have, but I will try to solve it from the uh, internet itself, the YouTube videos, right? What it is, that is variational calculation, secular equation, that is lecture number 46. Yeah, when I share this, you tell me for what is your particular doubt, and let me also check once what is. I'm currently checking these videos actually, secular determinant part. Acha, there is one problem in actually in assignment also there is a question, and if you solve, acha, I will tell that at the. Oh, there is a problem. Let me share my screen and let us start then. Yeah. I understand. That is what I am saying. From there, E becomes 0.125. I understand. That is a slight mistake is there in the slide. I'll tell you. In the question, in assignment also. So in earlier versions there was problem, but this time I have checked the assignments and updated the assignment in such a way that if you solve that, it will be that I will not say the answer what you have written, but yes, that will come. Acha, let me share my screen. Okay, I guess you can see my screen. Let us go to the assignment 7. Acha, you have a question. Did you write something? Mm-hmm. Okay. Assignment 7. Okay, let's start. So the first one is that turnover rule, that is for the Hermitian operator, we all know. So we are not bothering that much. So this is the first answer will be this. You will know. So the second is the expression for the first order correction to the energy from perturbation theory is delta E, that we already know from that doing that extensive calculation, that delta E or the correction factor will be something like psi k to the power 0. I mean, zeroth, or sorry, this is another mistake I am saying. Zeroth order uh, wave function, then that there will be the perturbation. Uh, Suppose the perturbation is h1, right? H0 is the normal. So this is the is if this is the overall Hamiltonian, then this is the uh, without unperturbed Hamiltonian, and this is the perturbed one. Suppose there is only one order perturbation is there. So it will be uh, so expression for the first order correction will be, suppose psi k, it will be uh, 0, right? Because for the nth order we already know that for nth order, okay, for nth order we already know that this is psi k and 0 h h dash, whatever the part of part is, and then this is n minus 1, right? So this is how the thing will come. So what will be the answer here? Psi 0 star H1 will be there, so C and D will be the possible answer. Okay, D will be the D will not be, because psi 1 star is there, so psi 0 H1. Yes, so C will be the right answer, right? C will be the correct answer. Then third one is the perturbation theory works for system in which the deviation from an exactly solvable Schrodinger equation is small, right? It should not be much. And for perturbation theory, it is there that we can work only with those systems for which perturbation means Schrodinger equation can be solved exactly, right? We cannot, uh, which is not the case for variational theorem, as you know. Then for the fourth one, I guess that is solved in the lecture itself. I think you got it right. If you have any doubt, you tell me. You can write in the chat. I can hear the sound if you have any doubt, yes or no. So I think this is the right answer, right? In the, I think it is done in the lecture video. If not, then we can go to question number 5. What the contribution of the x n in the polynomial expansion of x in the energy of enharmonic oscillator is. So as I think it is also discussed in the lecture video, right? So we have seen that for it will eventually come into the thing that if the overall thing is antisymmetric, sorry, overall thing is antisymmetric, then it will be 0, right? The integrand will be 0, and if the whole thing is symmetric, then it will be not be 0. So, oh, the thing is that so another thing we have seen that even though whatever the Hermite polynomials are, those are antisymmetric or symmetric, two Hermite thing are there, right? In between that polynomial, another x to the power n something perturbation term is there, right? So whatever is the written something. So,
Now I have joined from two.
okay, okay. So now we can use the audio, right?
Yeah,
You can do one thing in
yeah.
one device. You can mute yourself.
Yeah. One, my PC doesn't have a mic,
Okay.
and
So
I
you
have
do.
joined from a mobile.
So in mobile, you do one thing. In mobile, you just what you can do. Um, you can turn your mic on, but volume down.
Okay, 1 second. Okay,
And
better.
better maybe. Let's see. Let's see. I don't think there will be much problem. Okay. So let's. We are discussing about this question. Acha, there is one echo is coming. So yeah, Avinash, do one thing. Currently, you mute yourself. Whenever you have a doubt, just unmute yourself and you can we can discuss. Whenever you have to say something to me or if I am asking. Okay, that's better. So the thing is that for this case, what we have seen that whatever the Hermite polynomial is, symmetric or anti-symmetric, as two things are there, eventually if symmetric it will be symmetric, and
It's
anti-symmetric will
always
also be
symmetric.
symmetric, right? Yes. So all depend on this x to
Yeah,
the power
yeah,
n, whatever
yeah.
means perturbation we are using. So depending on that, it will
Yeah.
be symmetric or anti-symmetric, the whole thing. So the thing is that if
Hmm.
n is odd, then the whole thing will be anti-symmetric, so it will be zero, right?
Zero. Yeah,
Yeah, and
yeah.
non-zero for the even values of n.
Even values of n.
Yes, so these two will be the right answer, I guess. And then
Yeah.
for 6, again, the thing is coming like that. The expression for nth order correction to the energy of the kth order non-degenerate level of a system EKN is that we already know
Hmm.
that B is the right answer, right?
Yeah, that's
So
B.
this,
Yeah.
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 So this is will be the B. Sorry. So now
Hmm.
the thing is that for question number 7, you and Aurigopal both have a
Hmm.
doubt. So this will be a, good question to discuss. I have also checked before solving this. So see, the question tells us that
Hmm.
a particle of mass m is confined in a finite potential wave with the boundary condition. So whatever the boundary condition is
Hmm.
given, you can see this is not really a finite potential one, but you can see this is a infinite one, right? Because
Hmm.
whatever other than 0 and it is infinity, the v of x. So we already
Yeah.
know the wave function, right? You already know that
Hmm.
psi n is root over 2 by L sine n pi
N pi x
x by L, right?
by
Yes,
L. Right.
yes, yes. So we don't we will use this formula once to find out the E1. Okay. So the correction to
Hmm.
the first term is that is
That.
and E1 0, right? Because this n is not 0, n is
Yeah.
equal to
N is
1.
zero. Yeah.
N is 1 actually
Yeah.
because
N
it
is
has
one.
the,
N is one. Yeah.
yeah,
Yeah. Yeah. N
potential
doesn't
one.
have zero.
Sorry, yeah, finite infinite potential one, right? Box, particle in a box. So n will be
Hmm.
quantum number
Yeah.
is 1 at the ground state.
Hmm.
Okay, so these will be as we done from the previous thing that psi 1
Psi zero
1
or
0
psi one.
zeroth
Uh-huh.
zeroth actually it is a zero,
Yeah.
and then
Yeah.
v
Yeah.
p of x that will
V
write it as,
V.
yes.
Hmm.
Can you tell me? I will
And
write.
psi one zero. Psi one
Yes,
zero.
yes. Zeroth again.
Correct.
Zero will be
Uh,
a wrong thing to say. It will be zeroth.
yeah. It will be the unperturbed.
Yes. So then it is like, so let me open the thing 0 to L, right? Psi, this is
Yeah.
2 by L will
Two
come
L
because
will come out.
2 root over 2 by L are there.
Yeah. Hmm.
Then Vpx is also V naught something. So V naught is the constant term which you will keep outside the
Yeah.
integration,
Hmm. Hmm.
and the things will be there
Uh,
sine n pi
Sine
x,
square
not n, actually here n will be 1, right? Because
will be sine square
yeah, sine square. Sine
uh,
square, so let us not write
pi
that,
x
sine
sine
pi x by
L
l, and
in
actually another
sine
in between another thing will be there, right? The sine
yeah sine
2 pi
2
x by
pi
l
x by L.
dx will be there. So
Huh.
so now how to solve this? So we have to do v naught by l, 0 to l, sine not cube, right? Sine square pi x by l, sine 2 pi x by l.
Hmm.
Okay.
Hmm.
Okay. We can do one thing, that we can take these two inside. So this will become 2
Uh-huh.
sine square pi x by l. Sine
Hmm.
2 pi x by l is already here. And we already know that 1 minus 2 sine square theta is equal to cos 2 theta.
Hmm.
So 2
Huh.
sine square theta is 1 minus cos 2 theta,
Hmm.
right? So 2 sine square, so in that analogy, 2 sine square pi x by l will be 1 minus cos 2 pi x by l, right?
Yeah, hmm.
So it will be v naught by l, 0 to l, 2, this will be 1 minus sine
Hmm.
2 pi x by l into sine 2 pi x by l dx. So that will be eventually, let us write it there. So this is a simple thing. Sine 2 pi x by l once, and dx, and another will be always v naught by l, 0 to l, sine square 2 pi x by l dx. So again we can take a 2 here and 2 common there. So 2 will cut. So we will make it something like that. So let me take another page for this. Let me take a new slide, blank slide. Right here. So we have till now that E1n, E1 to the 1, that is V naught by L, um, V naught by L, sine 2 pi x by L, dx. One is that, and another is dx by 2L, 2 sine square 2 pi x by L dx. Now this will another analogy, it will be 1 minus cos 4 pi x by L. Right? So, and all this will be 0 to L integrals. So let us solve the first one. It will be V0 by L into L by 2 pi, and sine will be minus, I guess, cos uh,
Cos
2 pi x by L, and L to 0, that is 1. Means like this, and this will be still, we have to do something there, 2L, integration 0 to L dx, another will be minus minus plus. Am I doing it right? I don't know. Let's see. Cos 4 pi x by l dx. The ALL is cut there, is 0 by 2 pi. And what about this? At L, x is equal to L, this is minus cos 2 pi, right? At L will cut, and another will be plus cos x is equal to 0, overall thing is 0. This is 1. Then what is cos 2 pi? That is cos 0 in itself, right? So eventually you will see this whole term is 0.
Yeah.
1 minus 1 plus 1 it will be 0.
1 minus
Then
1 is 0, and over there it
yes,
becomes 0 minus 0, so it becomes 0.
yes.
This part I
So
got. E1 is equal
so
to 0, I got that part.
okay, so if you do this thing, so for others I am saying, so they can do themselves. So
Ah,
this thing for
ah.
E1 itself will come as 0. Okay. Now
Yeah,
we have to
that part
find
I
out,
got.
yeah. So we have to see what is
E2.
E2 0, right? Yeah.
Yeah.
So here it is given, all the things are given. So E2 is also like that. E2 is E1 2, sorry, with actually that's what I should say.
Hmm.
This will be psi 1 0, same VPX whatever the perturbation is there, and this is psi
Psi 1, 1, 1. 1
psi
first.
1 1, right?
First.
1.
Yeah.
So here the
Hmm.
thing is for already for we have shown you. Let me also I have also solved this. So let me check that thing from the Rayleigh Schrodinger equation.
Hmm.
And equation we have used to solve this thing, right? That psi kth psi k1th will be something like j naught is equal to summation of j naught is equal to k c j k to the power psi j 0. Okay, so here is a catch. You can see that CJK also we have solved from that slide. Acha, let me go to that particular slide of professor, so we don't have to solve much. Here you can see, right? So there has been some typos here, as you all know that JK will be VJK or this part, and divided by the denominator will be ek no, 0th minus ej 0th, right? So we'll use this thing there.
Sorry, can
Yes.
you repeat that? What was the typo?
Okay. So we are going to replace this CJK. What will be the value of
Hmm.
CJK? That is solved in the lectures. So I am not solving that. So
Hmm.
I was showing that how that CJK part was being achieved.
Hmm.
As you can see, CJK to the power 1 that has been solved, right? Like here, and the typo
Hmm.
was that I should be J
Ah,
here,
yeah.
right?
Yeah, it should be
As
J.
I think
Correct.
also mentioned.
Correct. Yeah,
So
yeah, 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 yeah.
we'll write that thing there. So
Hmm.
it will be like CJK part will be. So I'm just writing J not equals to K. This will be suppose psi. Uh, so let me also see so that I don't make any mistake. Psi j 0, so that perturbation term is there. Psi k to the power psi k 0, and um, it will be e k 0 minus e j
This EG, EJ
0,
0.
and don't
Yeah.
forget that psi j 0 is still here, right? So it is something like the Kate function is. Okay. So this is what that psi k. I mean, this is the first order correction to the kth psi k, right? So what we already know that this k should be 1 for the ground state, right? I will
Hmm.
come back to this, but from this also we can go that the second order correction for the kth is psi k 0, that perturbation, whatever perturbation is there, V, let us
Hmm.
say like that,
Hmm.
and
Hmm.
psi k 1. So we'll replace the psi 1 kth with this value. So let us go here only. So that
Hmm.
E k second will be. I'm just writing it. I think you have already solved this thing earlier, but I'm writing it multiple times so that it can be clear. Psi k 0, psi j 0. Actually, what I'm writing, I will tell you. So whenever we are going to replace this psi k thing with this whole part, so what we are getting that this summation is coming psi j not is equal to k. This is, first this part will be there, psi j 0 v psi k 0, that part is done. Now this psi k 0 will again come. Whatever there is the in the bra part, right? And the perturbation and psi psi, what will be there? J is already taken. I have done some mistake. Psi k, psi j to k and k, and there will be this jth time is there, right? In the kit. So this will be j 0. So is my handwriting visible and understandable what I'm writing? If not, please
Actually,
tell me.
no.
Okay. So are you seeing in your
Yeah, I
notes?
can, I can, I can read, but I don't understand what you did.
Okay. So you didn't understand what I did. So let me tell you again.
Yeah.
So we are currently finding out what is the second order correction to the energy. So for that, this is
Correct.
the formula, right? The psi k
Yeah.
0
Yeah.
v psi
Yes.
k to
Yes.
the power 1. That is the common
Correct.
formula we have used in n minus 1 thing, right?
Correct.
So
Correct. Correct.
yes, and from the Rayleigh-Schrodinger equation, we have found out
Hmm.
already what is psi k 1h, correction to the first order wavelength. So there is correction to the
Hmm.
energy and as well as to the wavelength. So using the Rayleigh-Schrodinger equation in the lectures, you can see that we have found out what is the psi k 1h. Okay, because we have found out that CJK, that matrix element, we have found out this thing, right? And we just put that thing into this summation thing, and this whole thing is the correction to the first order energy and first order wavelength, wave function, sorry. And then this first order wave function, we are putting this value.
So psi k first is summation of this.
Yes, psi k 1h.
Uh,
Then this value of psi k 1h we are putting into the energy correction, because the term is there, right? This psi k,
okay.
this psi k 1h term is there. So we are just
Uh,
replacing this value, putting
okay.
this value here,
Uh,
and so it will be something like, so let me write it here only. So the first, this part will come, summation thing. If
this
I
is from CJK. This from CJK.
CJK,
Uh,
one overall
yeah.
thing is
Yeah. This
that
from CJK.
CJK we have multiplied with that psi j 0 so that we
Hmm.
obtain
Hmm.
this first order wave. So
Hmm.
this thing will come first, that
Hmm.
I am writing again, j not is equal to k psi
Hmm.
j 0
Hmm.
perturbation psi k 0, and
Hmm.
denominator there is the energy
Divided by
E k naught minus
ek
E j naught.
zeroth minus ej zeroth.
Yes, it is there.
So
Then
this is the C. This is the CJK part.
CJK part, but still
Now
this
this you have to multiply with your psi j zeroth.
psi k 0. This part is here, psi k 0. Still this thing is there, right? Psi k 0 perturbation, and this kth part is left. So this is the CJK, this summation part,
Hmm.
and still this psi j 0,
The C.
this part is there,
Yeah.
that kth, right?
Correct.
So,
But then why
so
did you put a kid bracket after that in the second line?
so there will be two some there is actually double integration is there, as you can see
There will
from
be two
here.
summations. I got that part. No, no.
One summation,
See,
one
you wrote
summation.
this psi k. No, no. You wrote this psi k1 is equal to summation over j not equal to k. Yes, you can see
Actually,
this.
this is a Kate vector, right? This whole thing is a Kate vector. That
Ah,
is what I am saying. And we just replace
no,
the value of
no,
Cjk there.
no, no. It's not. It's not a vector. It's just summation over Cjk psi j.
So actually, this will, if you see that this will be, how can I mean, if you consider it to be a means some wave function is there, right? Psi j. So let us
Hmm.
not
Hmm.
complicate the thing with this Kate or this thing, right? So if
Hmm.
means we
Hmm.
can go through that part also. So for simplification, if
No,
you say
actually,
only psi j 0 is there,
the during the lecture,
yes.
psi k first was given as summation of Cjk multiplied by psi j 0. There was
That I think you can
no ket.
this is a mathematical function, right? So what is that thing is saying that to that psi k 1th wave function, what is the
Hmm.
contribution of this uh, jth unperturbed wave function? So that is what it
Hmm.
is being said here. So
Okay.
so you can write it the vice versa way also, that psi j 0 multiply by cjk.
Okay.
So what we are trying to do right now, that we are replacing this or putting this value of psi k 1th in the correction term,
Hmm.
and so it will become
Okay.
something like this.
Okay.
So ek naught, and this part
Okay.
is here, and psi k naught. This is what I have written here also. See this part, you can see my cursor, I guess. Here we have also written like
Okay.
this. Whatever I am writing here,
Oh,
I have written. So this is ek
okay.
naught, ej naught.
Minus E naught.
Yes. So now you will see that this whatever perturbation is there, that is Hermitian. So it will be something like that,
Hmm. Hmm.
uh, that psi j 0 v naught v hat psi k 0. This will be equals to this thing, psi k naught v naught.
Turnover rule.
Uh, yeah, turnover rule. This complex conjugate is. So it will be something like psi j 0 psi k 0 its square, magnitude square, because this is a complex conjugate, right? If something is complex, two complex will also give you real
Hmm.
number, right? Something like that, and
Hmm.
there will be e k naught, sorry, e k 0 minus e j 0.
Hmm.
So this is
Hmm.
your second order correction. So from here you can see
Hmm.
that whatever is the situation, the numerator is always positive, right? Because it's a square is there,
Hmm. Hmm.
right?
Hmm. Hmm.
It will be square, and its sign
Hmm.
will depend on this denominator, e k naught
Hmm.
minus
Hmm.
e j naught. And we also have
Hmm.
to remember that for these non-degenerate systems, what we are currently doing, j naught is equal to k. For this thing, that Rayleigh-Schrodinger equation has been derived. So for
Hmm.
our case, for in this purpose, k is 1, right? For ground state,
Hmm. Hmm. Hmm.
right?
Hmm.
So
Hmm.
you can see that E10 here is always going to be less than, sorry, I have written it wrong. Let me use the whatever one. I guess right now you are getting the point what I am saying, right? That whatever other uh, energy levels are there, that will be that Ej, that will be greater than this energy, right? Because E1th zero, that unperturbed whatever the energy is there, that will be the lowest energy, right? For ground state, when k is equal
Hmm.
to 1. So that
Hmm.
is why
Hmm.
this term here will be for ground state, it will be negative, right? Ek naught minus Ej naught means the k is 1 here, right? For a ground state.
Hmm.
So for ground state, Gs E k2 is negative. Why? Because the
Hmm.
upper part is positive because the square is there, but this
Hmm.
k minus j, the k is 1, and that has the lowest energy. So
Hmm.
you can understand that this
Yeah, yeah,
part will
yeah.
be negative. Do you
Hmm.
have any doubt here?
It will be always negative.
And not always. For depends on the k and j. Where is the means
Yeah,
what
but
is the
if
state you
k
are
is
choosing?
1,
K is
j
1,
has
then
to
it will
be a
always negative. Yes,
number greater than 1.
yes.
Hmm.
For this small answer, I have to derive this, but I hope this is clear right now, right?
Okay.
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 Uh, so, do you want 1 minute to grasp it, or
No, I'm okay.
okay? So that's all for this question, right? So this
Hmm.
actually this is just a concept actually. So in Levine and other things, it has not particularly been said, but I guess if you solve some problem from this book, I think this kind of problems will be there, and it can be solved. Okay. So for the seven, then what we have found out just now, that the first order correction to the energy will be 0, and the second order correction will be less than 0.
Hmm.
That will be negative. So the first one will be the right answer. Okay. So let us go to question number 8. Again, the same thing, that using Rayleigh-Schrodinger method, contribution toward a
Hmm.
non-generate state from the other state of the system is found to be more for states that have. So before that, let
If
me
the n
write
is
this thing. That
if the n is a
CJK.
closer,
Yes, this thing will be like that because psi.
the denominator
Uh,
is the difference.
yes, exactly. So that energy thing is there. So more closer this will be, the denominator will be more smaller, right?
Yeah. So CJK will be bigger.
Yes. So energies that are closer. So this will
Hmm.
be smaller and this will blow up.
Hmm.
So the more will be the um, contribution. And the last question is, a particle of mass m is confined in a potential well
Hmm.
with boundary conditions like that. Again, the similar boundary conditions. Did you solve this problem?
Yeah, yeah. This is very
Uh,
similar to what was solved in the video.
First one. Yeah,
Yeah,
video. I think
that
there is a
beta
problem.
by 2, beta by 2, yeah.
So it will be beta L by 2 or beta
No,
L
no,
by 4.
no, 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 no. Beta
I
by 2
don't.
was the previous answer.
Yeah, yeah.
Over
So
here it
yeah,
is beta, like very similar.
very similar. I guess you can solve.
Hmm.
You others can also solve
Yeah,
it. If they have some problem,
yeah.
then again we can come back to this problem tomorrow. So you had another question regarding that mm,
E dash and E.
E dash. So let us go there. So, so this is the third, right? This is the slide.
Oh, this is
Can you
on.
see this?
Yeah, this is the slide.
Yeah.
Yeah, I
So
can.
the mistake here is that can I write it here? I don't think. Can I write? No, I don't. I can't. Actually, this should be h square, not h cut a square. So if you take
Ah,
this,
okay.
if you take
Yeah, yeah.
4.93, okay, and
And
put
you
it
do 2
here,
pi.
yeah. So it is already
Okay,
divided
okay,
by,
okay.
I think, 4 pi square. So if you see that,
Okay, okay.
then
Huh. Okay.
it will be actually
Yeah,
h square.
because if it is just H cross, then
Then
it should
it
be
should
just
have been
4.94.
4.93. Yes, yes,
Yeah. So I didn't understand that how 4.93 becomes 0.125.
yes, yes. That is a sad said always the peril of copy paste. Maybe it is something like that.
Huh. Okay,
So
okay,
that's
right,
why I
right.
have
So okay,
updated
once
the
it is
assignment also. Yes.
okay, once it is H square, then we can work it out.
Yeah. The best way to do these things is actually, if you can solve it, the whole thing you can do once in pen and paper, it will come up.
Yeah, I did the whole thing
Okay, and
once,
yes, at last actually the thing will be
and I
confusing,
got
right?
the roots, which was very similar.
Yeah,
And but then this last step, I thought,
it was
what am
confusing.
I
Yes,
missing? Yeah, what
yes,
was I
yes,
missing?
yes,
Because all of a sudden I couldn't get 0.125 from anywhere.
yeah. It was 5, something like 4.93. Right? Yes.
Yeah, that's fine.
Actually, it is divided by 4 pi square.
Okay, so
4.93
it's
by
h
4 pi
square,
square.
not h cross.
No, no. It will be h
So
square. Yes.
it has to be divided by 4 pi square.
Yes. The same problem I think
Okay,
given
then
in
it's fine.
the assignment. So in assignment I have
Assignment.
assignment 8. Assignment 8. So there I have corrected that thing. Here I can't correct, right? So I have corrected that thing in the assignment. Assignment 8. Mm, are you checking that assignment? Okay. So that part is clear, right? This is I don't.
That 7.
Oh, okay.
7 is
Well,
actually, see, the problem with this assignment is that text is not word text, it's an image.
okay. Let me check that.
If you see, so the resolution is not very clear. So it is H or H cross, I really can't make out.
From assignment 8 you were saying?
Uh, yeah, no,
Acha.
assignment 8, yes, this is
And
7.
let me change my profile, or if I go to assignment 8, now the answer will show.
Yeah, no, no, no.
I,
Go out and show it so.
I just changed the profile because that was a teaching assistant profile. So anyway,
Okay,
that I have made sure nothing is there.
that's
Uh,
fine, that can be solved. It is
yeah.
H or H cross, I can't make out.
In assignment,
In assignment, yes, because
it is 8 square.
but that because that text is not a word text, it is a image,
Ah, it is
it's a
the image.
photo.
Actually,
So the resolution is quite poor.
I have given them the
Uh,
it is
See
a
now, if you
square.
zoom in now,
Yeah.
it is H square, not H cross.
No, it is h square. A square. Yes, yeah, it's poor. Yeah, actually
Yeah,
that was the problem.
that's the problem. So I can't make out if it is cross or not.
And now we have discussed. Did you submit it yet? Or I think tomorrow is the last date, right? Or you have submitted it?
No, I can submit again. I can submit again.
Okay, then it's okay. Then
Yeah.
you got it. Yes.
Actually, I solved it with H cross square.
Okay.
Okay, but I'll change that.
Okay. Okay. So that's all I think for today. Do you have any other queries?
Actually, one more.
Okay, tell me.
If you go to this turnover rule,
Okay, let me check.
the derivation, can you go there?
Yeah, I think I have that. The previous one. Relation and 38 maybe. Is it the thing? No, not 36, 37. Yeah, yeah, right. Yeah, right.
I can't see your screen.
Okay, okay, I have stopped it. Screen share. And now we can.
Yeah.
Yes, this is the thing.
Ahead, go ahead. Ahead, more. Ahead. Last part.
Last part. This
No,
we are going to. This
no.
is. I think you are saying this part. This. Um, what can I say? Um, are you saying about this part? How? Acha, here
No,
Seth
no, no.
writing it.
How is fine.
Hmm.
This, you have this integral
Hmm.
f, okay, integral f a hat star
Yes.
g star d tau is equal to g star a hat f d tau. Where
G
do we get
star
this?
star.
I am
Yes.
reading from my notebook, so I
Okay.
don't
Okay.
know where it is something.
Okay.
So basically, what my problem is, see, over here, I don't know where is it. Let me check on your slide.
Hmm.
Can you go one step ahead?
If I go one step ahead, it is something like that. It's from here, from this part, they are going
Uh,
because
okay, okay, then
we
ahead,
have solved this. This thing is
ahead.
equals to 0.
Yeah, 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 yeah. Then
So
ahead.
then
This
uh,
part, this part. No, 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 back, one back.
one back.
This one.
Hmm.
So it is F star
Hmm.
A hat G d tau, right?
Yes.
Is equal to G. Now G moves that side,
G goes to this side. Yes, the left hand side.
but A star A becomes A star,
A become A star. Yes.
and F star becomes.
So this is something like that. G, this A is now working on it. It
Hmm,
whole star actually something like that.
hmm.
So that is what I guess they're saying.
Can you write this thing same thing on the bracket
The
notation?
bracket notation,
So
right?
it will become F, then A G is equal to what we write is GAF, right?
Yeah.
When we write turnover.
So,
Whenever we use turnover rule, that's what we use.
G,
G A
A,
F.
A, and this will be actually a complex conjugate of that thing.
Ah, okay. Somehow I
So
miss
actually,
this complex conjugate part every time.
yes. So this thing is G star is already there if you come to that integration thing, and because this
Hmm.
is in bra, so that star thing will again go. So it will be something like G, and these two part will be in complex conjugate.
Okay.
That is the Hermitian
So okay.
case, and
In bracket this. So if AG is GAF star.
yes.
I always miss that star part
Okay.
during the lecture. I always thought it is FAG is equal to GAF. So that somehow didn't make sense.
Yes. Yes. Actually, let me show you one thing there. This is the Levine actually. So
Okay.
what can I see? Where can I get? Um, yeah, yeah. I was just checking for today's lecture that seventh number question. But here you can say I am going to highlight it.
Hmm.
This is psi m
Okay.
naught. Can you remember this thing?
Hmm. Hmm.
Let me highlight it.
Okay. Okay. There's a star there. Yeah.
There
Yeah.
is star, right?
Okay.
Okay.
But now I really exactly don't remember where it is used during the lecture. But
Okay.
during the lecture, the professor changes this, F and G.
Okay. Here only you can
You
see.
flip over.
Here only.
You flip over, but
Here. Even though it is flipped over, but the thing is that the overall thing is going to be 0. So 0 star will be again be 0. So if professor has missed
yeah, yeah.
some compress conjugate, that I think
Over there it is zero, but it doesn't have to be zero every time, right?
no, no, no.
Or yeah,
Wherever it
but
is being used,
yeah,
I think
yeah. No, no.
that
Whenever it is flipped, it is used for your annihilation operator.
yes, yes, yes.
That's why it becomes zero. Okay.
Yeah.
But during the lecture, he never mentions this star part.
Okay,
He
okay,
just flips it and say, and obviously it won't change a thing because it becomes zero eventually.
okay.
But since he doesn't mention that star, I always thought FAG is equal to GAF. Then somehow that never made sense to me.
Notion, yeah, yeah. I understand. I understand. Yes.
Okay,
Right,
okay.
right. I think right now it's clear, right?
Yeah, yeah, it's clear now.
Okay. Okay.
So there is a star for
There will be
turnover
a
rule.
step. Yes.
Okay, okay, okay. Yeah, that was my doubt.
Yeah.
Okay,
So this
that is it.
is also done, right? So let me unshare.
Yeah.
And any other doubts?
No, not for me.
So you have already you have seen the lectures from that variation theorem, right?
Yeah, I've done that. Yeah, that's
Okay.
finished.
Variation theorem is also done. I think week 9 is open. That is for Slater. What is there? Week 9 is a little confusing for me. Let me check what is there for week 9.
Secular
Week
equation.
9. Yeah, Hartree-Fock. No, actually Hartree-Fock thing is going to come.
Hartree-Fock. Huh.
Okay, that I think is
I
a little
haven't
bit
started that
tricky.
one.
Yeah, actually that is little bit more mathematical. Um, I found
Okay.
it tough for myself. Uh, but the whatever the assignments are there, you don't have to worry about that. The assignments are simple for Hartree-Fock.
Hmm.
We will discuss that Hartree-Fock later sometime. I also have to read a lot for this perturbation. Also, I have read some this today only. Today only means the day when we have submitted the updated assignment. I have done, but now again I had to
Hmm.
do to solve this question. So for Hartree-Fock also I have to read and then we will discuss that time. I hope I will clear some of your doubts, if not all. But let's see.
Yeah.
Actually, with Hartree-Fock, we will finish. Professor will finish the atomic part. Then that VBT, MOT, this molecular bonding,
Okay.
chemical bonding thing will come up.
Hmm. Hmm.
So
Hybridization.
hybridization that will eventually come up. Yes.
Hmm.
And then I think another 2 or 3 more weeks, then it will be finished. Okay. So
It's
okay,
over.
then
Yeah.
we can stop.
Yeah.
And
Yeah. Good.
Vajiravel, do you have any questions? Another guy is here. If you have any questions, we can finish then. Okay, I don't think he has questions, so let's stop it here. We'll meet tomorrow, next week again. Thank you for coming.
Next Tuesday. Yeah.
Next week.
Okay. Bye.
Bye.